party. The girls really enjoyed themselves. So I haven't had a chance to quite clean up yet. I do apologize. We're here today to talk about fire. Isn't that exciting? I know you all look excited. Remember, we're not in school, so please feel free to yell out randomly for no apparent reason. So we're going to go ahead and start off with asking you, what is the fire triangle? We're looking at fire, and the fire triangle are the fundamental parts, components for making a fire. Who's ever heard of the fire triangle? Great! How many of you have ever made a fire? Okay, so you guys already subconsciously know what the fire triangle is. Basically, it's very simple. You just put your mind at work. If we want to make a fire inside this cup, what do we need? I want a fire in there. What are we missing? Fuel. Fuel. Very good. Fuel. What else are we missing? Wood. Still a fuel. Okay. Good. Oxygen was one that was mentioned. That's good. So we have our oxygen. The last one, people are saying flint or ignition, spark. It's actually heat, and we're going to go into that a little bit later. So, add a little bit of heat. Obviously, this is ignition in this particular example. So here's our fire. What happens if I put that fire underneath the bell jar? Go out. Smother. I like that. Yes, it will suffocate and die. Now, the reason why is because there is a lack of oxygen, right? You have your oxygen here, the fire's burning it, but it burns up all the oxygen and it runs out. And you know what else it does? It makes a vacuum. Kind of fun. And that's because when it burns up the oxygen and then puts out carbon dioxide and water, the carbon dioxide and water occupy a smaller space than the oxygen originally did. So it makes a vacuum. Kind of cool. Alright, I'm going to move on from that experiment because that one's boring. You know why? Because the fire gets smaller. We want a larger fire. So, in this case, rather than taking oxygen away, we're going to add oxygen. To add oxygen, the garbage can with a bowl on a lazy Susan. What's going on? Well, we wanted to find a way that we could add oxygen to show you the impact of the fire. So what I have here is ethanol. Ethanol is our liquid fuel that we're going to use. So we'll add some ethanol there. Now I'm going to use another source of heat. In this case, it's going to be a match. Ain't that match? And this. Well, that was interesting. Apparently, I have psychic thoughts. Alright, so a piece of phosphorus goes ahead and runs in there prematurely. That's fantastic. So there's our pretty cool little fire. Pretty normal. What I'm going to do is I'm going to pump it full of oxygen by giving it a little spin. See, it makes a tornado. It's kind of cool. So what's happening is, as it's drawing in the oxygen is being filtered through the garbage can and forced into spiral motion, kind of like those Dyson vacuum cleaner commercials. So round and round and round it goes. If I stop it, turn it the other way, again it forms this tornado effect. Now these tornadoes are actually seen in reality. They do exist. The largest one was spotted in California in 2003. And it was about, I don't know, this is about 2 feet. So it was about 1,500 times this height. It was about a kilometer. 1 kilometer of spitting fiery goodness. Some pretty scary stuff. And it's very, very dangerous because they travel so quickly. So how do you think firefighters could tackle a fire like this? What do you think they use? What are some tools? Water. Right. So water, they could just use water bombers. Okay, so you're using water bombers, it's still not quite doing it. What's another thing you could do? Sand. Sand could work. CO2, we're already doing that. It's called global warming. Not helping. But I like your idea. I like your thinking. So, try and take away the oxygen. Difficult to do because it's the atmosphere. Add water. Excellent. Try and cool down the fire that way. That would work. Third option. If your fire is rushing toward a city and there's some forest here, you can cut out some of the forest. That fire is going to rush up, hit the clear-cut area, and it's going to starve a little bit trying to jump over to the other side. While it's stuck there, pummel it with everything you have. And that's one way of putting it out. But they are very dangerous, and it's just because of that added oxygen. When you add one part of the fire triangle, it kind of pulls all the other ones apart, thus making a larger triangle. Now, moving on to another, not really a component of this fire triangle, more of a subcategory. This is surface area. I know that brings back horrible memories of math class, but it's okay. The surface area is basically what? The exposed surface, the area of the surface. It's kind of hard to define. Here. If I grab, piece of paper. Here's our piece of paper. The surface area of this paper is this size plus this size plus all the skinny sides. Okay? Now, if you were all oxygen molecules, you guys would need to be touching this paper so that I could light it on fire. But how easy is it for all of you guys to squeeze in to touch this piece of paper? Is it easy or is it hard? For all of you guys to squeeze in to touch this piece of paper at the same time? Pretty hard. I would have to agree with you. So, what if I do this? What if I start ripping pieces apart and giving you each a piece of the paper? Is it still the same paper?
Yeah.
Yes. All I've done is increase the surface area. And that works in the same fashion here. Here I have a mysterious white powder. Not the mysterious white powder you're thinking of. And what I'm going to do, try and set it on fire. Come on. So I got lots of heat. We have a little bit of oxygen. I think we got to turn the lights right out to try and see this fire. Alright, here we go. I'm going to try again. Yeah! Fire. Then it goes away. And that's because of a lack of surface area. Without that surface area, there's just not enough oxygen contact to make a difference. So, we have option number 2. It's the same powder, but in a funnel. And the funnel is hooked up to a balloon pump. So, we have a heat source, we have oxygen, and we have a powder. Now what I'm going to do is launch the powder into the air. That'll increase the surface area and increase the flame. 3, 2, 1, go. That's bigger than this. I'm going to say yes. So all it is a difference in surface area. And surface area plays an important role in, for example, campfires. You go to make a campfire, to start off, you have to have little sticks. You have to have kindling, you have to have paper, you have to have things that have a lot of surface area and that are dry. You have the rookie sometimes who grabs a log this big, hauls it into the pit, and then uses all your matches trying to light it. Not going to work. And it's a lack of surface area in addition to probably being full of water. So, a little bit of a factoid for you. Now the other important aspect is this powder is actually quite common. And when it's churned up like that, it can actually be explosive. For example, if you Google grain silo explosions, the big silos you see, if they're full of grain, they typically have a no smoking sign. That's there for a reason. In Wichita, Kansas, in 1998, there was a massive grain silo explosion because someone was smoking where they weren't supposed to be, and it blew up. It was full of grain. It wasn't full of anything you would think would be that would work as an ideal fuel. But when churned up and there's enough surface area, bad things can happen. So very, very important to note. Next thing covers the last type of fuel that we've yet to cover, because we have solid fuels, liquid fuels, and gaseous fuels, right? So, the gas fuel we're going to use is a fuel that you've all used, I'm sure.